So we are now going to move on to part 2 of the assignment, which is a demonstration of an application. So the application I have chosen is emotion and facial expression recognition with OpenCV, which is number 23 on the application demo list. So this application is used to detect emotion or facial expression such as sadness, anger, or happiness on a person's face. So in this case, the application uses a deep learning classifier that is loaded into OpenCV's DNN module. And the model was trained using MS Cognitive Toolkit, and then it was converted to ONNX format, which is Open Neural Networks Exchange format. The dataset was trained using FER plus dataset. Normally, the standard dataset for emotion recognition is the FER dataset, but the FER plus dataset has been labeled by more than 10 crowdsourced taggers, so it provides a better quality of ground truth label for emotion detection. So in order to be able to detect the facial expression or emotion, we have to firstly detect the face. And to detect faces, we have used the bleed face detector library, which is used for facial detection and uses for different algorithms. So here the bleed face detector has been used. So now let's move on to the code part of the program. So now we are going to look at the first function, which is init underscore emotion function, which is the first function that is called from our main program. So the init underscore emotion here has argument model, which set the path to the model on our disk. So the model is stored in the model folder. Then we define a list of 8 different emotions that can be detected on a person's face using this application, which is neutral, happy, surprise, sad, anger, disgust, fear, and content. Then we initialize the DNN module that is read the model, and to use the model in ONNX format, we use cv2.dnn.readNeck from ONNX and pass the model inside this function, as we can see here. So this is what the function init underscore emotion does. So the other function is emotion, and takes as argument the image, which is the second function used by our main function. So firstly, it makes a copy of the image. Then in this application, we can detect more than one faces in an image. So if we have 3 people in an image, it can detect the emotion on the faces of all the 3 persons. So when we detect the faces in the image, and in order to detect faces in the image, we use an SSD based face detector with a 20% filter confidence in order to detect faces. As we can see here, this is a SSD based face detector, which is one of the detectors in the bleed face detector, and the conf is equal to 0.2 defines a confidence threshold on 20% defines a confidence threshold of 20%. Next, we have padding is equal to 3. So here the face in the image is being padded by a value of 3, which expands the face boundaries so that the model can look at a larger face when it is predicting the emotion or facial expression on the face, and this can help in giving much better results. And here, for each faces that was detected in the image, we extract the X, Y, W, and H coordinates. This will be done for all the faces in the image. The X and Y or X and Y coordinate, W is the width and H is the height. Then here we get the padded image. When the image is converted to grayscale, because our model takes a grayscale image of 64 by 64 resolution. So we have to convert the face to grayscale and also resize the face so that it is of resolution 64 by 64. So 64 by 64 is the size that our model requires. Then here we are reshaping the face into 64, 64 because this is the final format that our model requires. And here we input the process image to our network, that is the model. And here the image goes through the neural network where most of the computation takes place. And here we are computing softmax values for each set of scores. So our model, in fact, it will output scores for each emotion class. So it will output different scores for each of the emotions. Then here, so we are converting the model scores to probability between 0 and 1 by applying a softmax function on it. And then we obtain the final probability. And here we get the predicted emotion by the model and print the predicted emotion. So to be able to get the predicted emotion, so we get the index of the max probability that we get when we convert the scores to probabilities between 0 and 1. So we get the index of the max probability and then use that index to get the predicted emotion in the emotion list that we have above here. So we get the index of the max probability and use the index to get the predicted emotion in the emotion list. And now that we have obtained the predicted emotion, to display a better output, we display the image with the predicted emotion and we write the predicted emotion on the image using the function putText. Then we also draw a rectangular box over the detected faces, as we will show in the demo soon. And then we display the emotion. And now we have obtained our output with the emotion detected written on the face. So since in the function emotion the return data is false, so if return data is true here, else since return data is false, the image will just be displayed. So this is what the function emotion does. So now we are going to move on to the main function. So when we run the program on the command line, we can specify the image that we want to use as argument. And if no image is provided as argument, then by default the Vinasha image in the media folder will be used. So firstly, the main function will call the function init_emotion. Then it will read the image, whether it is the image we have provided as argument on the command line or the default image being used here. Then it will provide the image as input to the emotion function, as parameter to the emotion, which as we have described previously, will display the predicted emotion along with the image. So let's try running the program without specifying any argument and see what output we get. So the program is called emotions.py. So I'm going to run the program without specifying any image as argument. And so this is the output that we get. As we can see, the predicted emotion happy is displayed as we have printed the predicted emotion in the emotion function, and also a square is around the face detected and the emotion is happy, as we can see here. So in our media folder we have several images, so we are going to run the program on the emotion 1 image, emotion 3, emotion 2, emotion 4. We are going to run the program on different images. So let's run on emotion 4. And this is the output that we obtain. Here it is neutral. The emotion is neutral. And let's try on other images. So this is on emotion 2. As we can see, happy, happy. So this is the output using another image. So this is the output using the emotion 3 image, which is the emotion detected here is sad. So here we are detecting emotions only on one person's face. So let's try with images having more than one person, and let's see if it can detect the emotion on the different person's face. And here is the output that we obtain using an image with two people. They are both smiling, so it has detected two faces and both happy. And as we can see, it has detected two emotions. So again, let's try with another image. So we have now run the program with an image of two girls. And the emotion detected here are neutral and happy, so it has been able to detect the faces of the two girls and the two different emotions. Now we are going to run the program with an image with several faces and see the output. So this is another output. So in this image there were 6 faces, and all 6 faces with different emotion has been detected. Here is happy, where the person is smiling, neutral here also. Here has been detected as anger, here as happy also. So this is the output.